it's parallel to BC, and A is equals to B. Is it clear so far?
Yes. Yes,
Okay.
ma'am.
Now at first we are saying here these two are parallel. That means AB and CG are parallel due to construction. Okay, which implies that this BE will be parallel to CG. Okay, and EF, it's parallel to BC. It's given. This implies that now this implies that EF and BC are parallel. That means EG and BC will be parallel. Therefore, EGCB is a parallelogram. Now, if you are thinking, will it really help us proving this two triangle are congruent, this two orange color triangle? Let's check it. We are going to take this two triangle now in triangle AFE and triangle CFG. Okay, let's write angle F over here, angle F over there are same, vertically opposite angle, right?
Yes.
What else? So parallel line, you are already having the condition. Okay, parallelogram, you already know this two, this completely it's a parallelogram, and you also know that this CG and AB completely you have taken parallel. This two completely. Okay, that's the given. I mean that's the construction we have taken. That CG and AB are parallel. Okay, this construction is going to help us. Can you see there are two parallel line and there is a transversal over here?
Yes, ma'am.
This is a transversal. Okay, two parallel line, the black colored are the parallel line and this is the transversal. Then alternate interior angle will be same. Yes or no? Yes or no?
Yes.
Okay, so we will say angle A over here. In the first triangle, angle A, okay, FAE is equals to, in the second triangle, angle C, FCG. These two angle are same. Why? Because AB it's parallel to CG. Okay, and these two are pair of alternate interior angle. Clear? What else can be taken? Who will tell?
Angle A is equals to angle C.
Angle E is equals to angle. Can you please repeat?
Angle A equals to angle C, but alternative interior angle.
Yeah, just now we have written angle A and angle C, right?
AE is parallel to CG. It's equal.
AE is equal to CG. C. E is the midpoint. A, B is same, right? Right, everyone? Yeah,
Yes.
that we will be using. Okay, A, B is same. And since it is a parallelogram, just now you have declared that it's a parallelogram. Opposite side must be parallel and equal in length, right?
Yes.
Okay, that means opposite sides are, I'm just writing over here directly, we will be writing over there just for your clarity. I'm writing over here, still you don't have to note down anything, just focus. So if this is a parallelogram, EGCB is a parallelogram. That means opposite sides are parallel, which we know. And opposite sides are equal also. EG is equals to BC and BE is equals to CG, right? Right?
Yes.
Okay. If EGCB is a parallelogram, EGCB parallelogram, opposite side parallel and equal. Equal condition I have used over here. And can you see BE? BE is same as CG, and it was given in the question that AEB is same. Can you see that AEB is same given in the question, and now you are saying that BE is same as CG. There AE and BE equal. Here BE and CG equal. That means all three are equal in length. Yes or no?
Yes, ma'am.
Okay. So we
Yes,
can say AE, BE, CG. I am highlighting it in the figure. AE, AE is here. This much length. BE is here. This much length. And CG, this much length. What we are trying to do, we are trying to take those two orange color triangle we have taken. So yeah, we can use that AE and CG are equal in length. Yes or no?
Yes, ma'am.
yes,
Making sense to all of you?
yes, ma'am.
Yes.
So here we will say that the length AE over here is equals to the length CG over there. And yeah, we need to give the complete declaration that why these two are same. Okay, so we will say from the given condition, let me write it. We will write from the given condition. Okay, it was given that A, B same, and since it's a parallelogram, EGCB is a parallelogram. Therefore, EGCB is a parallelogram due to that this length. Okay, this just a moment. So we are saying that this length BE is equals to CG. And these two condition are giving us that AE BE same, BE CG same, and hence AE and CG are equal. Clear?
Yes,
Is
ma'am.
it
Yes, ma'am.
okay? And now we are done. You are having a triangle over here. You are having a triangle over there. You have compared this angle with this angle. You have compared this angle with this angle. And now you are saying the side, this one, and the side CG, this one are equal. Okay, this side. Okay, so or maybe this side. Let's mark it. If I'll mark it in any one of the triangle, it is angle, angle, S side. Can you see? SAA, those property doesn't exist. So angle, angle, side property in the other triangle also, it is angle, angle, side. Can you see that? Is it clear to all of you?
Yeah.
Yes, ma'am.
It is angle,
Yes.
angle, 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 side. By angle, angle, side, we can say these two triangle are congruent with each other. And the moment you are declaring these two are congruent, you are done with the proof. Okay, you are done with the proof. You will say that already you were having a triangle. Okay, in that triangle, EF was there. Yeah, you have extending it till G and you have joined it with C. It was A, it was B. Okay, the moment you are saying that this triangle AEF, it's congruent to triangle, I must write the name properly. Okay, what does that mean? That means that writing the angles, whatever is equal, properly by doing the arrangement. So angle F and F must be at the same place, and angle C over here, angle A over here. So C and A, I will maintain the placement, and yeah, I got the name. It has to be CGF. Clear?
Yes, ma'am.
Okay, these are the basic which you need to follow every time, no matter you are solving question from quadrilateral, question from circle, or maybe question in class 12 or class 11 or class 10. You will be using this concept every time, everywhere. You will be maintaining the name, you will be writing the properly, writing the property carefully. So it is by angle side. Now what we wanted to prove same, we wanted to prove same that the other side, okay, one of, we were having a triangle. In that triangle ABC, E is the midpoint, we already knew. This line segment EF is parallel to BC, we already knew. And we wanted to prove that F is also the midpoint. Now from after proving this two triangle congruent, see the arrangement of the triangle's name. We will be able to say that AF and CF are equal. Can you see that AF side, okay, the length of the side AF and the length of the side CF are equal by CPCT, and it is coming from the name of the triangle. Forcefully we are not saying. Is it making sense?
Yes, ma'am.
Okay, so we can say now AF is equals to CF by CPCT, and we are done with the proof of converse of midpoint theorem. Now, okay, from here we can say AF is equals to CF by CPCT. Okay, I'm going to summarize this proof, then I'll give you time to note down everything properly. So let me summarize the proof. At first, we were having a triangle. ABC. Okay, in that triangle, E is the midpoint already given, and we are supposed to prove that F is also the midpoint. Given that this EF is parallel to BC, we knew already. Okay, so we know that we have to extend it like this, which we have done in the midpoint theorems proof as well. And we know that we have to join it like this. Okay, while extending, what condition will be taking while doing the construction? We have to take a condition. Okay, which condition will be taking? We are not sure about that. Okay, that how we will go ahead with the construction. But for now, we are sure that we will be taking this triangle and we will be taking this triangle, and if we will be able to prove these two are congruent with each other, we are done with the proof. We can say AF over here and CF over here same. Hence, F is the midpoint. F bisect the third side. Clear?
Yes.
Okay. But the construction, what exactly will be taking? In midpoint theorem, we used to take that the length of the sides are equal. What length? We used to take that EF and FE are equal, right? Over there we have taken that let's say the length EF and the length FE are equal. So here also, if you are thinking about the same, that why not we are taking the same construction, that EF length and FE length are same. So yeah, let's take it. Let's take it, then prove the congruency. Okay, is it possible to prove congruent? You have to prove that AF and FC are equal. It's not given at all. Okay, so don't say by mistake that AF, FC are equal. So what you know in this two triangle, vertically opposite angle. And due to the construction, if you are thinking about taking the construction in this manner, okay, you can check it. It will not help you, because now you are having just two condition, one vertically opposite angle and one EF and FE same. Anything else? No. Anything else? No. Okay, you don't have any other condition. Do you have? Okay, that's why here we are taking, there is one way, but that way can be, okay, little bit complicated. So that's why here in the theorem, no, just parallel condition is given, just parallel, that EF is parallel to BC. Okay, so the half one condition, EF is half of BC, that we are not using over here. Okay, because in the theorem it is only written that E is the midpoint and EF is parallel to BC. So we are just trying to use only this much information, and yeah, construction we can do. So the construction which you are taking just like midpoint theorem, that only is not helping. That's why we are changing little bit the construction, and we are saying this time we will not take equal. Okay, this time we are not going to take equal. Just a second. Just a moment. No? Can you hear me?
Yes.
Yes.
Just a moment. Yeah. So we are saying this time we are not going to take the construction exactly like the midpoint theorem. This time we are going to change the construction. What we have done this time, we have taken the construction in such a way so that this and this are parallel. Okay, now is it helping us proving our two triangle are congruent? Because we just want that, nothing else. Okay, so yeah, it is helping us. We can say that vertically opposite angle, one more angle due to the parallel line, and one more condition we are getting over here due to the parallelogram condition. Okay, due to this parallelogram, the moment we are doing the construction like this, already one parallel condition we were having in hand, and now another side also became parallel. Already we know that this two are parallel, I mean this two are parallel. Okay, and in addition to that, this construction is now helping us by for the saying that this BE, wait. I think by mistake I have taken the same point again and again. This is G. So now we can say that BEGC, it's a parallelogram. Construction and the given condition helping us. Okay, since it is a parallelogram, opposite sides equal and parallel. Now we know due to the given condition that this AE and this BE was same. If this is X, this is X. And due to the parallelogram condition, we are saying opposite side of the parallelogram must be equal in length. So this will also be X. Okay, because it's a parallelogram. This is X, then this will be X. And due to that, we can say CG and AE are equal. Okay, and we are done with congruency. We are done with congruency, and we can say we are done with the proof. Is it clear to all of you?
Yes, ma'am.
Is it crystal clear
Yes,
to all
ma'am.
of you? Everyone getting it? Why not
Yes.
we are going like that? Okay, why we are taking this approach? Okay, what exactly is the purpose? Why we are doing the construction? Everything is clear to all of you?
Yes, ma'am.
Okay, I'm scrolling up. Please note it down. Initially, a statement is written. If you want to copy the statement as well, I'll scroll a little bit more up, and then you can take the
We
statement.
need to copy the theorem.
You can copy the theorem if you want. Otherwise, the statement is also there in your book. But if you are copying, just either write converse of midpoint theorem proof or copy the statement as well. Otherwise, later on, when you will go through this proof, you will get confused that this is the proof of what, which question number. Okay, so either just give the heading, or along with the heading, you can copy the statement as well. If you are giving the just the heading, that means the statement is clear in your mind. Okay, that's why you are not writing the statement. You will just read the heading anytime, anyway. Okay, after 1 month, 2 month, you will just read the heading, and you will be able to realize this is a proof of what. Otherwise, copy the statement as well.
Ma'am, theorem statement, right?
Yeah, theorem statement.
So I know the statement, I mean. So can I
Okay,
wrote
you know the statement, then you can start with the proof.
with construction, I will do.
Yeah. Let me know once you are done. Are you done, everyone? Can I scroll down? Can I scroll down?
Yes, ma'am.
Is it fine?
Yes, ma'am.
Okay, do it. Meanwhile, I am taking the next question. I mean the one and only one and the last question from here. Let's do the next one. Everyone, are you done with this one?
Yes, ma'am.
Yeah, ma'am.
Okay, let's move. And let's take this number 7. Okay, ABC is a triangle. Meanwhile, I am finishing the writing part. Read this question and try understanding what the question says. Okay. Okay, let's see what the question says. ABC is a triangle, right angle at C. That means I need to draw a right angle triangle. Okay, a right angle triangle ABC, which is right angle at C. This is how the triangle will have a line through the midpoint M of the hypotenuse. Midpoint M is there for the hypotenuse. Okay, a line through the midpoint M of hypotenuse AB and parallel to BC. Okay, like this. Okay, parallel to BC, intersect AC at D. Show that D is the midpoint, right? This is really simple, right? In a triangle ABC, M is the midpoint, okay? And through this midpoint, a line segment is going and going and going and going. And this is not a random line segment, okay? It is clearly written in the question that line which is going through M, okay? It's parallel. See, ABC is a triangle, right angle at C. A line through the midpoint, M of the hypotenuse, AB, okay, a line through the midpoint and parallel to BC. Can you see that parallel to BC? Basically, I just want to show you this much. This line is not a random line. It is parallel to BC. Yes or no? If it
Yes,
is parallel to BC, that means we can use converse of midpoint theorem. And we will say by converse of midpoint theorem, D must be the midpoint. Yes or no?
Yes.
Clear?
Yes, ma'am.
Okay, and
yes,
yeah,
ma'am.
we are done with the first part proof. You have to do it. You will say in triangle ABC, just 2-3 step and we'll be done. In triangle ABC, okay, M is the midpoint of AB. M is the midpoint of AB and DM, it's parallel to BC. M is the midpoint of AB and DM is parallel to BC. Therefore, D must be the midpoint of AC. And in bracket, you need to write by converse of midpoint theorem. Clear?
Yes, ma'am.
Now you have to prove that MD is perpendicular to AC. MD, it's perpendicular to AC. Okay, it is making 90-degree. Just a moment, let me check what can be done. MD is perpendicular. If I'll take two triangle which is congruent with each other, just a moment. No? Meanwhile, you finish the first part proof. Okay, yeah. So to prove MD is perpendicular to AC, we need to join this M with C. Okay, then only we can use this two triangle and we can prove the congruency. And after proving the congruency, easily you will be able to say that yeah, MD is perpendicular. Why? Because after proving this triangle number 1 and this triangle number 2 are congruent with each other, you will be able to say that angle D over there and angle D over here are equal. And since both are equal, but both added together is making linear pair. Is it making sense? Is it making sense? You are
Yes,
going
ma'am.
to say that angle D over here and angle D over here same due to congruency. At first you will prove congruency, then you will say angle D over there, angle D over here same. If that is X, this is X. But both added together is making linear pair as well, 180 degree. And from there we are getting each one will be 90 degree. Yes or no?
Yes, ma'am. Yes, ma'am.
Okay, so this logic we'll be using. Now the question is how we will prove this two as a congruent. Okay, do we have enough data available? So yeah, that's what I was checking, that do we have enough data available? And I realized that yeah, somehow we have enough data. Again, I'm just drawing the just a second. Yeah. So you are having a triangle like this. Now since here 90 degree, okay, and a line is coming through M. But this line is not random line, it is parallel. So can we say that here 90? Wait. Before taking the congruency, I think directly we are able to say that it is perpendicular. Wait, just a moment. No, I think directly we can say that just joining M with D and this two are parallel line. These two are parallel and this is a transversal. If here 90 degree, then here there must be 90 only. And here 90, then there also 90 only. Oh yeah. Okay, why we will do congruency and all? Directly we will be able to say MD is perpendicular to AC. Can you see that? Can you see? Yes or no?
Yes, ma'am. Yes.
Okay, we don't have to use this triangles and all. What I'm trying to say, we know that this BC and DM are parallel. Yes or no?
Yes, ma'am.
Okay, and angle C is 90 degree. Okay, if these two are parallel and there is a transversal and AC is transversal, which means that angle C, okay, the complete angle C, you can write it as a angle ACB plus angle MDC added together will be 180. Co-interior, yes or no? Interior angle on the same side of transversal, right?
Yes, ma'am.
Okay,
Yes.
and one of them is 90 degree, then the other one will be 90 degree. We don't have to do anything at all over here. Okay, automatically we are getting that angle MDC will be 90 degree. If MDC is 90 degree, if MDC is here 90, then the other part will also be 90 only. Okay, so therefore here only we can say MD is perpendicular to AC. Clear? Is it clear to all of
Yes,
you?
ma'am.
Anyone having any confusion? No? The third part is still we are left with the third part. Yes, Gauri, Chakrika, Lokya, Afia, Tanisha, are you getting it?
Yes. Yes, ma'am.
Okay,
Yes,
the
ma'am.
third part that CMMA is equals to half of AB. CMMA is equals to half of AB. Okay, here we need to do the construction. Okay, I realize that this is one of the question where we have to join this two. Okay, that's why I was joining this two. This CM and this MA, these two are equal, which is half of AB. Okay, yeah, now you need to prove these two triangle are congruent, and very easily you will be able to prove that 90 over there, 90 over here, DM common side. Okay, so directly I am writing for part 3. Please prove it, that triangle CMD, it's congruent with triangle. Okay, let me write the name properly. Angle D same, side MD common. So the name will be CMD and AMD. Yeah, these two will be congruent. Let me check the criteria by which these two will be congruent. This common side we are using AD and CD. Okay, AD and CD are equal. That we are using, which we have proven the first part. Common side we are using, and 90 here, 90 there we are using. So that means side angle. Okay, SAS. This part I am leaving for you. Okay, you cannot write directly this two are congruent. Please show this two are congruent. Okay, after that, after proving this two are congruent, now you can say the third part, that the length CM and the length AM is same. Okay, and we know since M is the midpoint, M is the midpoint of this AB, the complete side AB, M is the midpoint. So AM is nothing but half of AB, right? And CMAM is same. That means CMAM both are equal to half of AB. Is it clear?
Yes, ma'am.
Okay, so this hint you can take. This is the hint. This again is the hint. Okay, you can take it. The third part, you have to do it all by yourself. We are done with quadrilateral. Example question you need to do by yourself. Okay, I have not taken example question over here. If you will tell me to take any particular example question, I'll definitely take it, but for now I want you to go through it. Never ever miss any example question while doing the while learning any chapter. Okay, even here we are discussing example or not, your job is to practice example as well, not before any test. When you are learning the chapter, then, and of course after that, every time you are revising the chapter, you are revising the examples as well. Okay, this is the bare minimum you are doing. So yes, we are done with quadrilateral. I am keeping this much over here. Okay, anyone having any doubts so far?
No, ma'am.
Okay, so yeah, keeping it this much. Thank you everyone, take care of yourself. Thank you, bye.
Thank
Yeah,
Thank
Thank
you, ma'am.
you. Bye.
yeah, bye. Hi Nikhil, hi Rayan. How are you both? Can you hear me?
Fine.
Okay. So we were doing surface area and volume, and we are doing volume of the sphere. The moment like few questions are there, and today we'll just finish this chapter. We had done till question number 3, right?
Yeah, ma'am.
Let me take the next set of questions. Yeah, can you see the screen?
Ma'am.
Okay, again
Yeah.
here it says that question number 4, the diameter of the moon is, wait, is it the same question which we have done? What fraction of the volume? Okay, previously we have found the fraction of surface area, and here we are finding the fraction of the volume, right?
Yeah, ma'am.
Okay, so yeah, fraction of the volume, the diameter of the moon is approximately 1/4 the diameter of the earth. So if the earth's diameter, it's d, then diameter of moon will be d by diameter of moon will be 1/4 of that, right?
Yes, ma'am.
Okay, 1/4 of d, that means d by 4. Now in each case we need to work with the radius, okay, because the formula for finding the volume of the sphere is 4 by 3 pi r cube, right?
Ma'am,
So
what? Can I
radius,
repeat the formula?
it's 4 by 3.
Volume, yeah, 4 by 3 pi r cube.
Yeah. Okay. Radius will be diameter by 2. Okay. Volume of earth will be 4 by 3 pi. I'm just keeping as it is because we need, at the end we need to find the ratio. Okay. R, the radius is this one. So whatever is the radius, that cube. Clear so far?
Yes, ma'am.
Yes.
Okay. You can simplify it again. Whatever is possible. If you want, you can do the simplification. And I'm keeping this much over here. Directly, I'll show you the final simplification while finding the ratio. However, if you will do it over here, it will be really easy later on. So if you want, I can show you the simplification, little bit simplification over here as well. See, this is nothing but 4 by 3 pi, and this will be d cube by 2 cube, right?
Yes, ma'am.
That means 4 by 3 pi d cube by 8. 4 2 times 8. So you are going to get, okay, you'll be having 4 by 4 gone. So basically you are having pi, just pi d cube by 3 2 times 6. Clear?
Yes, ma'am.
Okay, now we need to work on the moon as well. So Earth's diameter is d, therefore diameter of moon will be 1/4 of that diameter, d by 4. Radius over here will be whatever is the diameter, that divided by 2. Fraction says that do the reciprocal. So divided by 2 can be written as into 1 by 2. That means d by 8. Okay. This is the radius. We must not get confused. Now we'll be finding the volume. 4 by 3 pi. R is this one, d by 8 cube. We'll have 4 by 3 pi d cube by 8 cube. Okay, 8 into 8 into 8. So for 2 times 8, you are having pi d cube over, you can multiply all of them. You are having 8 times 64, 2s are 64 into 2, 128, and 128 into 3, 384. Okay, so volume over there and volume over here. Any confusion so far?
No, ma'am.
Okay, now we will be finding the ratio. Okay, the ratio between the volume of earth and the volume of moon. Okay, volume of earth. Let me check how it is asking the ratio. What fraction of the volume of earth is the volume of moon? Yeah. Wait. What fraction of volume of earth is the volume of moon? Okay, so you can find the ratio anyway, earth by moon or moon by earth. Okay, but at the end you have to find in this manner your answer. What fraction of the volume of earth is the volume of moon? Okay, volume of earth multiplied with what fraction is means is equals to, okay, the volume of moon. Making sense?
Yes, ma'am.
This way your answer should be there. So if you want to find earth by moon, go ahead. If you want to find moon by earth, go ahead. I will be taking moon by earth. Why? Because directly I can tell the fraction then. Why? Because moon is there in the numerator, this earth I'll take in the denominator while finding the ratio, and exact ratio, just I need to change the side. Making sense?
Yeah.
Okay. Yes, Rayan, are you understanding that you can find volume of earth by volume of moon, or you can find volume of moon by volume of earth? Making sense?
Yes.
Okay, but the question says that volume of earth multiplied with what fraction is equals to the volume of moon. So in this format we need to write the answer, and for that reason only we are going to find the ratio between moon by earth, not earth by moon. Okay, so that directly we will get the fraction and we will not get confused, okay, doing the reciprocal and all. So let's do volume of moon by volume of earth. Just now we have found the moon's volume as a pi d cube by 384. By volume of earth, better write divided by. Earth volume was pi d cube by 6. Okay, pi d cube by 384 into 6 by pi d cube. Clear so far? This two gone. 6 times 36. 37, 38. 6 4 times 24. So we are getting 1 by 64. Is it clear so far?
Yes, ma'am.
Okay, now we can say volume of moon is equals to 1 by 64th of volume of earth. In this format only we were supposed to find the answer. Any confusion? Please do it. Yes, Rayan, please do it. Yes. Any confusion, Nikhil, Rayan?
No, ma'am.
Please do it. And once you are done, please let me know.
Ma'am, can we last question, the same format we got the surface area question, right, ma'am? So for that we used both the formulas to cancel out the 4 by 3 and pi value. So can we do that in here in the starting itself?
Yeah, exactly same way we can do it. But while doing the calculation, you have to be careful. The terms must cancel out each other.
Okay, ma'am.
If you are able to land at 64, okay, 1 by 64, that means, yeah, you are doing it correctly. Are you done?
Yeah, ma'am, 1 minute.
Yeah, do it.
Yeah, ma'am.
Okay, let's take the next one. Yes, Rayan, are you done? Yes, Rayan.
Yes, ma'am.
Okay. Let's take the next one. How many liter of milk can a hemispherical bowl of diameter 10.5 centimeter can hold? A hemispherical bowl you are having. The diameter of this bowl is given over here as 10.5 centimeter. Okay. How many liter of milk can this bowl hold? See, volume of the sphere is 4 by 3 pi r cube. And volume
Ma'am,
of
so
this
hemisphere, it's 2 by
half.
3 hierarchy.
Half of this one. Okay, that means volume of the hemisphere is half of that volume. Volume of hemisphere, it's half of the sphere's volume. If you'll do half, the formula was 2 by 3 pi r cube. Yeah. Okay, here diameter is given, radius you can find and you can put it over here to get the final answer. Can I leave it?
Yes, ma'am.
Okay, number 5, I am leaving it because directly it's based on the formula. Diameter, Ryan, diameter is given as a 10.5 centimeter. Radius you will be able to find by dividing it by 2. 10.5 by 2 will be 2. 5 times 10. Okay, 2, 2 times 4, 5.25. Either you take like that or you just take 10.5 by 2 and just put it over here. Okay, and then do the calculation. Clear? Can I leave it, Ryan?
Yeah.
Okay, so yeah, question number 5 I'm leaving for you because the straightforward formula is there. Now question number 6. A hemispherical tank. A hemispherical tank we are having. Okay, a tank which is in the shape of hemisphere is made up of iron sheet 1 centimeter thick. Is made up of iron sheet which is 1 centimeter thick. Okay, if the inner radius is 1 meter. Yeah, the inner radius of this tank is 1 meter.
Ma'am, so we have to add that 1 centimeter to that 1 meter. 1 point, it's like,
Okay, inner radius is given as, yes, Nikhil. Inner radius small r is given as 1 centimeter. We also need to find the outer radius over here. What is the outer radius of this? Okay, just a second. Just a moment. Yeah, I'm talking about this circle. This circle's radius also you need to find. So you will say outer radius is equals to inner radius, which was 1, plus thickness. Okay, in this question, Ryan, see carefully, thickness is mentioned. Okay, a hemispherical, I'm talking about question number 6. A hemispherical tank is made up of iron sheet 1 centimeter thick. The thickness over here is 1 centimeter. Okay, 1 centimeter. Wait, if the inner radius is 1 meter. Okay, wait. I have to maintain the unit. Inner radius was 1 meter and thickness is 1 centimeter. Okay, thickness over here is given as 1 centimeter.
Yeah.
That means 1